So I've just looked up the connection that I need to make to put this piece of wire in place. What I'm going to do is connect the middle of these 3 pins on the regulator here to pin 2, which is the second pin down on the ESP32. So you can see that's quite tight to that capacitor there. Now I think actually that capacitor is also connected to 3V3, which is the line that we're looking for. So let me just check that out. Yes, so that larger pad of the capacitor here is actually the same place as this pin here. It has quite a narrow, a thin bit of wire between the two, but it might allow me just to bridge across there a bit more easily. I don't have to worry so much about not joining this pin to the capacitor, because they are already joined and intended to be joined. So I'll try to do that now. So I'm going to hold the, I'm going to put a little bit more solder onto the pin here, hopefully trying to avoid bridging anything, and then I'm going to hold it at about a 45-degree angle like this, and then I'm going to try and make a soldered joint neatly that doesn't bridge across and does capture the end of the capacitor as well. Need a bit more solder on there to make that work. Oops, that's unintended. So, oh, that's interesting. So that demonstrates that I hadn't actually managed to solder the other end of that capacitor, which is quite interesting. So I'm going to just burn off a little bit more of this enamel here to make that section a bit longer. And I'm going to redo the capacitor that I didn't do properly before. Now attached itself to a different pad. Right, let's get that in place. Let's do the other end of this now. Right, pretty sure I've got both ends of that on now. And now let's try again with this idea, putting this in place to bridge across here. Probably a smaller soldering iron in this situation would be useful, but I'll persevere and try and get it to work with this one. Okay, so I think I'm fairly happy with that. I'll have a proper look with some magnifying equipment and just make sure that that really is okay. It's not great actually, the quality of the joint from at the end of the capacitor isn't that good, so I'm going to just retouch that. That looks better. Yeah, okay, I'm pretty happy with that now. So that was quite fiddly, but hopefully you'll be able to get that to work for you. And then if we just route that cable down, a piece of wire down here, and snip it off at a suitable place, about there, and then And do the same thing with this end, try and scrape off some of the enamel to start off with. You can just burn it off with a soldering iron, and to be honest I do tend to do that quite often, but it's probably a bit healthier to try and scrape it off first. As I say, the smoke from these things is not particularly good for you, so I'm just moving myself out of the way so I don't breathe that in. And then, oops, just make a bit of a mess there. But there we are, there's that piece of wire in place now. And we can just put it up the side of the module just to get it out of the way a little bit. Okay, so that's the only modification to the board that's needed. And that's all the use we have for that little bit of wire. And now we can press on and put some of the other components onto the board. I think probably the next set of things to do are these integrated circuits. There's also a few discrete components over here perhaps that we could put on first. So there are these two FETs that are used. One of them I think is, well, this one down here is certainly used to drive one of the bus lines. Can't actually recall what that one up there is for, but we'll come back to that. So I'm going to put those in place. Now what I tend to do is put them through and then just bend the pins out slightly, the outer pins, just to hold it in place. So now that's not going to move. And the same thing with this one. Don't bend them too much, just in case you ever need to take these out. If you bend them a lot, then it makes it very difficult to get the component out. You have to pull really hard. But if you just do enough to hold them in place, then at least while you're putting other components in, they'll stay where they are. So then there's the LED. So it's not very clear on here which way around the LED goes. I'm pretty sure that there's supposed to be a flat here, and that would show that it's the cathode of the LED. I'm just going to check that on the schematic. All the schematics are on Easy EDA, so if you look on, and you can also get to them through my blog post on this board, which is on robdobson.com. So yeah, I'm just checking the schematic now. Yes, so that is indeed the cathode. So that means it's the shorter of the two pins on the LED that goes into the upper hole, as we have the board orientated at the moment. So that way around. So we'll put that in as well at this point. Same thing, just going to bend the pins so that it holds in place. I think those are all the things that we probably need to do right now. I seem to remember that putting this component in relatively early was a good idea. It's a bit fiddly to get it between other components if you put it in too late. So the orientation of this component does matter, and you can see marked on here there is a square pad at one end of where that component goes, and that's the pin 1 position, which is marked on the component with a small dot. I'm sure you can actually see that, but there is a small dot there. And it's the writing on the component is just here. So maybe at some point you can see there's a little bit of writing there. So that's at the end, certainly on this component. That's at the end with the with where pin 1 is. Now this is a point where I'm going to use gravity, So I'm going to just try and hold that in place, and so it's good that I hadn't put any bigger, taller components in before now, because I can now just use gravity to hold that in place for me for a moment, and I will solder one pin. Now I'm going to solder this end, the left hand end for me, and the reason I'm doing that is because actually one of the components I put in, probably the LED, is a little bit taller than that, so it wasn't quite pushed right down, and it's also not quite vertical in the board, so I can make use of the fact that I've only soldered one pin and put my thumb on it like this, and then I can just reset that joint. So I'm going to just reheat that joint up, and at the same time I'm going to wiggle it into a more vertical position and into place. So you don't have to worry too much about how good a joint that is, because we can always redo it. Okay, so that's held in place now by that one joint at the end, and now I can finish that component off, solder all of its other pins. Some people like to use a vise or some other way of holding a PCB. I've never really got used to doing that. I always just find a way to prop it up or hold it in my hand somehow, or just keep it in place with one of my fingers while I'm soldering with the other ones. But if you have one of those and you find it useful, then by all means go ahead and do that. So that's that component in place, and now I'm just going to solder in these FETs that we put in. So they have quite small pads, so it's quite hard to make sure you don't bridge these, so just be extra careful with them. Don't put too much solder on, and then visually inspect them afterwards to make sure pretty much everything can be found by visual inspection in my experience. Now this second FET, I didn't manage to get it to sit quite as tightly to the board as I wanted to. The first one is sitting nice and tightly, but I've only done soldered one of the pins so far, so I'm just going to reheat that. I might have actually soldered two, but I'm just going to reheat both of them together while I push it into place with my finger. So I can't really show you both sides at the same time, but I've just done that, and that's now nice and tight to the board. It's always a good idea to try and get components as tight to the board as you can. And now I'll do one of the pins that I didn't solder before, just in case I reheated something and it fell back out again. There we go, that's those, and then the LED. So this is the tallest component I've put in so far, so I can actually just use pressure with my finger here to hold it in place while I solder it. But it's still not quite in the right position, it's slightly off vertical, so I'm again going to get my thumb onto it, solder the back. There we are, now it's in the right place. Nice and tight to the board and vertical, and then finish up with the final joint, and now we can lop off the unwanted material. So you don't want to do this too close to the board, so I would say maybe at least 0.5 millimeter, probably a bit more if you're concerned about it. So nice and neat, but not so close to the board that you actually remove the joint. This is a through-hole plated board, so it's not so important as it would be on other boards. If you have a board that doesn't have through-hole plating and just has. So here I've noticed there's a tiny bit of solder here between these two pins, which I'm not very happy about. I'm just going to try and remove that with my nail. It's not wanting to go, so I'm going to have a closer look at that. Yeah, so it actually isn't a piece of solder, it's just a bit of, I don't know what it is, but a bit of white material, but I'm just going to go over it with the soldering iron just to make sure. Yeah, it's not moving, so I don't know what that is, but it doesn't matter. It's not solder. So so there we are. We've got those components in place. So as I said, now I think it's time to start putting the chips onto the board. So we'll work through. Perhaps the easiest thing to do is to put the big ones in place first. So there are 4 of these 74 LVC245s, which are level converting octal bidirectional tri-state buffers. So these are the way that the Raspberry Pi gets access to the Z80 bus by reading data through these bidirectional buffers. So it can both put data onto the bus, the data bus for instance, so one of these is used for the data bus, and it can read the whole of the data bus in one direction, and then when the chip is set into operating in the opposite direction, it can write the whole of the data bus. So if I try and put this in place, so there are 4 of these, 1, 2, 3, and the 4th one's over here vertical. We need to be very careful about the orientation of these chips. They're not all in the same orientation, so we just need to pay attention to where the little notches are. I say they're not all the same orientation. The only ones that are different actually, the only one that's different is this one. But this, if we remember this surface mount one that we put in place, that is actually the opposite way around. It's pin 1 is over on this side, and these are all to the right. So just be careful about that, especially if you're soldering the chips directly into the board. If you're using sockets, it's less of an issue because you can always take them out and put them in the other way around, but it does mean that you would have put the power onto the chip in the wrong direction, and that can damage some chips. So this is going to go in. I'm going to put this one in position here. Now you can see that it doesn't actually fit. The holes, the legs on the chip are actually kind of splayed out, and the holes are the right distance apart for the separation between the legs at the shoulder, not the separation of the legs at the bottom where they're splayed apart. So that means we have to bend the pins to be more vertical. The reason these chips are manufactured like this is that when they're inserted by a machine, the machine squishes the pins in, and then they naturally spring back out again, and that holds the chips in place while the machine's inserting them. So, but we're not a machine, so we're going to have to bend them. So what I do is I tend to hold the chip like this with my fingers, and then I get my thumbs and I roll the chip forwards. This is actually something my uncle showed me how to do once. It's always worked very well for me. So there we go. Not quite. So you can just check when you've got them into pretty much a vertical position. Now the holes in this board are actually quite big, a bit bigger than they need to be, so you probably don't need to go all the way because there's a bit more tolerance than there might be with some boards. But there we are, that one's now in place. And then we'll do the same thing for the other 3 of these. That will do the same thing for all of them in a moment, but we'll maybe, actually, it's probably easier just to solder each one in place one by one, so we don't have to worry about them falling out when we turn the board over. So let's do that. So I'm just going to check again that I've got it the right way around. So yeah, the notch is at this end, and that means pin 1 is here, which is the square pad on these components, so that's correct. So I'll just make sure it doesn't fall out while I turn it over, and then I'll just quickly zip down the side of this chip and solder it in place. Now again, I like the chips to be hard up to the board, and this one isn't quite as far in as I would like, so I'm going to do the same thing that I've done before, put my thumb on it and push it in that last bit while I've only got one pin soldered. That just ends up ensuring that you end up with a neater result. So let's go down them one at a time. We'll get used to the amount of solder that's required for each pin, and it's a sort of, so the way I tend to do it is heat the joint up and then just push a certain amount of solder in. Now these, as I said, these holes are much bigger than they need to be, so they're actually sinking up a lot more solder than you might expect, or I might expect. I'm sort of used to the amount of solder that I have to push into a joint, so I have to remind myself to push in a bit more in this case, otherwise it's not really fully filled. Okay, it's working down. Okay, so rather than waste your time with all the rest, I'll put it in the rest of those components and then come back to you.